Hey everyone, today's lesson is going to be over nonlinear systems application problems. So today we're going to have a word problem. We're going to have to graph these and then interpret that point of intersection. So it is going to be very similar to what you did in yesterday's lesson. So let's go ahead and let's get started, and by taking a look at this first word problem here. It says a ball is kicked from a cliff and its height is modeled by the equation y equals negative 5x squared plus 10x plus 40, where x is the time. From the same location, a small rocket is launched and follows a straight path represented by the equation y equals negative 5x plus 40. So we're going to have to use both of these equations here to answer the following questions. At what height will the ball and the rocket collide? And how many seconds after the rocket is launched will it hit the ball? So again, we have two equations in this word problem, so we're going to use Desmos and graph both of those equations. We're going to start with the quadratic. Okay, and then let's graph the linear function. Okay, so we can see, let me kind of move this around a little bit here. We can see that there are 2 points of intersection, but if you do think about this word problem here, if x is representing your time, we're not really concerned about any of these negative x values over here because time can't be negative. So the ball and the rocket are actually going to both start right here at this first point of intersection, their y-intercept, which is 0, 40. So the ball is being modeled by the blue parabola, and the rocket is being modeled by the purple straight line right here. So we can see that the other point of intersection is right here at 3, 25. So that is the point of intersection, but how do we interpret that point? So again, just kind of going back to that, telling you that x represents time, well then that point of intersection, let me pull that up again, the x value in this is going to represent your time, and then the y value is going to represent the height. So the height of the ball, the height of the rocket, that's all represented by the y value, and your time is represented by the x value. So when it's asking you at what height will the ball and the rocket collide, we're looking for the y value of the point of intersection. Okay, so that one is going to be 25. And then the second question says, how many seconds after the rocket is launched is it going to hit the ball? So remember, we said that seconds is going to be represented time by the x value. And the x value for that coordinate, again, let me pop that up because it disappears each time. The x value for that point of intersection is going to be 3. Okay, so let's go ahead and let's take a look at the second example here. It says John and Sarah are each saving money for a car. The total amount of money John will save is given by the function f of x equals 60 plus 5x. The total amount of money Sarah will save is given by the function g of x equals x squared plus 46. After how many weeks x will they have the same amount of money saved? So again, we can see that this word problem has 2 equations in it. So we're going to go ahead and enter those into Desmos. You don't need the f of x. You could change it to a y if you would like. It's not necessary. It's still going to graph the same thing. So we can type in 60 plus 5x. And I can barely see my line over here, but we're going to zoom out here in just a second. And the second equation is x squared plus 46. Okay, so I can't see that parabola, so I'm going to pause here and I'm going to readjust my window. Okay, so now that I have that readjusted, we can see the 2 points of intersection, again, the parabola and the line, and I moved my question up here so we can actually answer this question. So it says, after how many weeks X will they have the same amount of money? Well, we see that there are 2 points of intersection, so if I click on that point right there, I can see that my X value, because X is representing weeks, is a -2. So you have to think about the context of these questions now. Is that an answer that we want? So no, we don't. Weeks can't be a negative value. So we're going to look at our second point of intersection up here, which is 7, 95. So to answer this question, after how many weeks will they have saved the same amount of money, we can say, because weeks is represented by X, we can say after 7 weeks. So then the point of intersection also had a Y value. So do you know what the 95 is going to represent? If you guessed it, that's how much money that they would save, then you are correct. So at 7 weeks, both John and Sarah will have saved $95. Okay, so make sure that you're utilizing Desmos in order to graph your system of nonlinears, and then make sure you're understanding how to interpret your point, what's represented by the X value of the intersection and what's represented by the Y value.